We're back here at Bill Howell's car barn. You might notice a few things that look familiar in the background, but anyhow, this is Bill's 2627. It's kind of a, we're going to call it a 2627. Don't really know what it is, but at any rate, roadster pickup. And Bill has used this car quite a bit for touring, and I've toured with him. We'll take off and do 3,000, 4,000 mile drives. So this has been a real dependable car. It's got at least 30,000 miles on it, maybe more. Just guessing here from some of the tours that we've taken. And it's been very, very dependable. Coming home off of a tour, all of a sudden the thing just quit going forward. The engine ran, but it just didn't have any power to the rear wheels. There was no pops, no clunks, no crashes. It was kind of thought, well, maybe we broke a rear axle because this car does have a set of the disc rear brakes on it, and thought, well, if the rear axle broke, maybe the disc brakes kind of held it in place. So it got towed home, and we immediately dropped the rear end out of it, looking for a rear axle, and the rear end was solid. Nothing was wrong with it. The next piece in line would have been a universal joint, but again, we never heard any clunks or noises. The universal joint was fine. Everything was made up through the torque tube, through the drive shaft. This does have a Lane's Warford transmissions in it. And so that's the next piece in this chain. Remember, I said the engine ran, but we just couldn't go forward or reverse or anything. So the transmission, auxiliary transmission, was dropped out of it, and it checked out just fine. It was kind of baffling at that point in time. We've got an engine that runs, and we have no power to the rear wheels. Well, this is kind of a first. Lo and behold, and I'm going to use this drive plate, and I've got a universal joint here in my hand. The drive plate has a square hole, and the universal joint has a square input. The Lang's Warford has the same square input. No universal joint is used, but this is what locks that drive line together. This car here, you've heard of putting a square peg into a round hole. Well, we can do that. This is completely gone. It's just wallered out. It's almost like it was machined out. We have no idea what caused it, but it's got to have the engine taken out in order to repair it. So we're going to pull this engine out, and we're going to use this engine as a video of going through and measuring. In other words, we've done a complete rebuild. Well, this one here, we're going to go into it and measure and mic everything and check and see if we're within tolerances. And if all we need to do is replace that drive plate, we're going to put this car back together and see if we can get another 30,000, 40,000 miles out of it. So that's our project for this video presentation is we know what our problem is. We don't know how much more we're going to find that we need to fix, but we're going to pull the engine out and we're going to go through it step by step, measure and check everything and say, this is good, this is bad, and go from there. So stay tuned. We're going to have a lot of fun here. So that was a quick couple hours. Well, maybe even a little longer. We took a lunch break, but at any rate, engine's out. So a couple of things just wanted to mention, and this is one of my favorite. Back in here at the back, there's the, what do we call that, an anoid? I think that's what it's called. That they tell you need to use with aluminum head on a steel block, and that's usually where I find them, right there. So them aren't really a very good thing. Looking at the valves, it tells me that the valves, we weren't running this engine very rich. In fact, if anything, we might have been running it a little lean, but there isn't a whole lot of carbon buildup in it. The head is clean. So had the carburetor set about the right mixture. So run down the road pretty good. So we're going to dismantle it, take the pan off, get the hogshead off, get the pan off, get the alternator off the front, and flip this thing upside down and start doing some measurements, see where we're at. Pan's off. Hogshead got off, took the pan, hogshead off. First thing we're going to do is check and see just what kind of runout might be on this, and also show you our square hole that is now round. That is supposed to be square for the universal joint to go in, or in our case where we were running that Lane's transmission, the square shaft would go in here. And that's just almost perfectly round. We have this round hole, which should have been square, and we're going to try to look for a reason as to why that might have happened. So I've zeroed out my dial indicator, and this runout here, man, I like to see it less than 7, 4, you know, something like that, because you do have a little bearing play in it when it's brand new. But let's watch this dial indicator as I rotate this thing around. Well, there's a there. Well, there's where am I? Is that 100? That's 100 around. I'm at 8. I got 85 thousandths run out there. Maybe 90. So I don't know. I don't know. That's an awful lot of run out. And something, I can wiggle it back and forth. 30, 50. Something's really, really loose in here. So we're going to go ahead and take this transmission apart, pull it out, and examine what's going on there. The drums from the exterior surfaces, they're nice. And even the Kevlar bands that's been in it for 30,000 miles, at least, they're actually in pretty good shape. This one got a little warm maybe, but they're actually in pretty good shape. The bands aren't very round. You could go ahead and use these, but we'll probably take the bands off and reshape these steel bands to where they're the right shape so they wear a little better. But they really aren't in that bad a shape for 30,000. So we're going to take the transmission apart, and we'll talk about what we find. Stay out from getting around the front side of it too. I like to go ahead and take the transmission apart while it's on the engine rather than pull the flywheel off as an assembly. Also, due to the fact that we're trying to figure out what all might be wrong with it. That drive plate has been ground on. That drive plate, I ain't too sure. I'm not looking at a washer that's been welded on it. I don't know what I'm looking at. Somebody did a nice job of safety wiring it. Pull the pin, and now I can look at the spring, and we'll check this spring. We want that spring to be above 90 pounds and preferably up around 115. So we'll check that. I also like to look at the back side where the 3 fingers are running. Make sure, I've seen some of these that are really gouged out. And this one's got quite a bit of wear on it, but it's still okay. probably go ahead and use it. I see something here that just, I don't understand quite what I'm looking at. I don't know what I'm looking at. Somebody's went in here, maybe they've welded. I bet you they've welded this sleeve to that and then came in and ground this all down, because this is really rough looking. You might want to get a picture. Okay. So what I see is a very amateur job of putting rivets into the drive plate. Very, very amateur. And I have no idea what in the world they had in their mind as to why that's all ground off. I'm going to go get another drive plate here just so we can compare. I don't know if they tried to weld the rivets into this side and then tried to clean up the weld, or just what they've done. I'd have to try to take that one apart, but boy, that's a real poor job of putting that together. It seems solid though. Yeah, it's solid. We have a Watts clutch. And it was installed correctly. Slipped a little bit, but we found that Watts clutches will slip under a heavy pull on our dyno. Not bad, but not enough that you'd ever hear it in the engine, but we do know that they'll slip a little bit. That clutch is serviceable. We'll reuse it. And that play is not, it's not like the main shaft's loose. It's just, these drums are just, the bearings is plumb gone. We'll get into that. It was safety wired. That's okay. That's another way of doing that. This is one of the reproduction, and it's the one tool that I've come across. Actually, my good friend Bill Howell gave me one that actually works. Actually works better than the Ford tool, I think. Yeah, I've retired my Ford one. This thing actually works. It's kind of nice that you can get something that will really work. Little persuasion's needed here. There. So the inner clutch basket, inner clutch drum, I think I think that's what they call it, inner clutch drum. That needs to be tight on the main shaft. You don't want that to be loose. The set screw just actually holds the key, holds it on its key with a little pressure. So you want this to be snug, and that one was snug. I look at the back side where the thrust washers, the 3 thrust washers go. Make sure that that isn't all galled up. We'll check after we clean up things, we'll check and make sure that we got good crisp edges on it. We're using a Watts clutch, so it should be just fine. I got a cotter key in here that should be in fairly. There we go. I've removed the key out of the main shaft, and there should be a minimum of 3, and depending on how much wear, there might be an extra shim. Depends on who rebuilt it the last time. Got it. No, got it. Got it now. So there's 3 thrust washers. And if you see these being discolored, it could mean that it was set up a little tight. These aren't bad. I've seen them where they were black. I mean, just completely black. There's a thrust clearance between the brake drum and the inner clutch drum. And if memory serves me right, it's 17 to 22, I think, is that number. We'll have to verify that. I'm old, I forget stuff. So these aren't bad. Can you use them again? Yeah, they're a little grooved, but we can use them again. The important thing is to set up the thrust correctly, and then we don't have a concern. 26, 27 drums have removable lugs. And I'm just dragging my finger down them, and they've got a little bit of wear on them, but we've got a Watts clutch in it, which is a thicker disc. So we really don't even need to change out them. And here's where the fun gets into. Okay, number 1. There's a bearing on a triple gear, and as black is what that rascal is. I'd say that got good and hot. Yep, looky here. You can see the triple gear pin is blue. That's a case of it getting hot, and at one point in time it probably galled it on it, stuck, and then allowed it to start spinning on the triple gear. And lots of wear in it now too. So it was set up probably too tight originally. And that triple gear, that one's stuck on there too. You know what? We probably have a, look at all the, somebody strawberried that. Trying to make that work. See all the prick marks on it? Somebody's took a punch and tried to raise that up and stick it in there. That isn't a good idea. Same thing on this one. So maybe they got cheap here and decided not to put in a set of triple gear bushings. I don't know. There's a lot of wear in it. So that probably spun on there because of, well, it just wasn't installed correctly. We'll have to measure. We'll measure the bores on these and see if we've got a good interference fit. If we don't, we'll replace them. You might decide you want to shim them, but we're going to replace them if they're bad. We're going to move out to the workbench to where I can go ahead and take the rest of these drums apart while we're here and see if we can find what we find. Puller to pull off the driven gear so we can separate the transmission. And sometimes you have to hit these, and sometimes they're really tough, and other times not so much, but this is how I do it. I clamp it up. I clamp that up in a vise. Popped loose. And that should be a good press fit. If it isn't, go find some better parts. But there's probably a lot of them put together that aren't very tight. After we clean everything up, we'll look at the gear. We'll make sure that the gear doesn't have any excess wear on it, and we'll examine it to make sure that we like it. That one's got a little wear on it, but it's probably okay. See if we can get these keys out of here. That's one, and that's two, and that's a splinter. What do I keep coming up with chunks of metal for? There we go. Okay, so our brake drum has removable lugs that we could change out if they're bad. I'm going to grab hold of it. I'm going to see if I can wiggle the shaft. I don't seem to be able to. We'll take this back over to our main shaft, and I think a lot of our play is in this. This measurement here should be about 1 inch. I have a sneaking hunch it's bigger than 1 inch. We'll clean up these drums, but just right now, visually looking at them, I don't see any cracks. But we'll wash these down and run them through the bead blaster, and it'll show up any cracks that's in them. But that looks like a pretty decent drum. It might be a little on the thin side, and that is your low speed. And it's got some color in it. That's that band that was black. So that band had been rubbing on this thing for a while. Seeing as how we got better drums, we'll probably change that one out. It's a little thin. Boy, there's metal shavings. Ooh, from somewhere. Okay, so that bearing wasn't too bad, and I know this one, as tight as it was to get off, wasn't too bad. After we get them all washed up and cleaned up, we'll check, but we may not even need to put bushings in it. But let's move back over to our main shaft and see if this thing see if this isn't where all that play was. Back at our engine, I'll just drop this brake drum on it, and all of my rock is in the 2 bushings that's in the brake drum, and there's probably 8-10 thousandths, where factory on that would be about 2. So that's would contribute. Remember, that drive plate sticks up here a little taller, and so some of that 85-90 run out that we saw could be contributed just to the fact that those bearings are so loose. We'll set up here and check our run out on the main shaft and see if it was centered on the crankshaft, and and then that might give us some insight as to what's happened here. I have a set of dial indicators set up here, and I want to read what I have run out at the bottom and run out here at the top or the upper bearing and see just what we've got. I'm going to rotate the crankshaft around, and the top one started off at 0, and I've got, well, I think I could say I got an honest 5, okay? And if I read the bottom from 0, I've got, there's 6 thousandths run out here, and I'm back to 0 here. So it tells me that the main shaft is off center of the crankshaft, not on center line, and it's got about a 5 thousandths, also about a 5 thousandths cock in it. In other words, the main shaft is leaning over. Not only is it off center, but it's leaning over. That, when I get up here another 5 inches with the drive plate where the 4th main runs, that is certainly contributing to some of that 90 thousandths run out that we had. Another thing that I want to look at is, remember, I had a 5-6 thousandths run out here at the top bearing that would be in the brake drum. Let's just go up and take a look at what we've got where that main shaft ran, or the drive plate, excuse me. And so I'm just going to set up real quick, and usually these are worn quite bad, and I expect to see a lot more run out here. So I'm zeroed, and I'm going to rotate this thing around, and there is 12. So there's 12 thousandths out around just here, and that's probably, the most of that is going to just be because that's worn. This bearing surface is worn. So in my opinion, I would find a better main shaft or replace it with a new one. Remember, we've got 2 bearings, and then that 3rd bearing's up here. Of course, we have the 4th main. If everything's in alignment, the load probably is really carried here on these 2 bearings on the brake drum, and the 4th main is supporting it, and that probably has some impact, but not a whole lot, but that's definitely way out around. Let's go back over to the workbench, and we've cleaned up our drums a little bit, and let's take a better look at our drums and check them for cracks, whether we're going to use them, whatever. And then we're also going to check the balance on them. I suspicion that they're way out. So let's go over there and take a look. Got our balancer and our transmission drums gathered up here. Did a little cleaning up, a little further cleaning up on the drums. So we're going to look at them and make a determination whether we like them, use them, throw them away, junk them, find them, do whatever. Starting with the low speed drum, if you remember, you can see it's quite discolored. And if you remember, the transmission line band that was on it was a little black. So this drum has seen some heat. However, looking in the webs, typically you're going to find them cracked in the webs. Obviously, you might find them cracked across the drum surface. This one doesn't have any cracks across the surface, band surface, nor are there any cracks in the webbing that are showing. The rivets are all good and tight. The drum isn't loose, other than the fact that this drum has seen a little heat. And if you look at the thickness of this drum compared to another Ford drum, you can see there's a substantial amount of difference between these two. And if I set one drum on top of the other, I'm not going to measure them, I'm just going to line them up here to where they're flush on one side. You can see quite a difference in the OD of the drum. So what I think happened here was this drum is quite a bit undersized. In order to get the low speed to lock up on the band had to be quite tight, which caused it to drag. But we got 30,000 miles out of it, so it didn't crack it, didn't break it. But with this drum being so thin, I would not put this drum back in my car. Now that would be me, because I'm going to drive 5, 6, 7,000 miles a year, easy, maybe even up to 10. If I was just going to go to the coffee shop and do a couple of small tours, and you know, I don't drive my car over 500, 700,000 miles a year, well, yeah, I'd probably put that drum back in it, because I'm not going to, you know, it's going to take me 5, 6, 7 years probably to get a lot of miles on it. But whereas I would not use it, because I'm going to take off. I might be gone on a 6,000 mile drive, leave the house and just go for 30 days or better. So this would be a drum that could be used, but I would only put it in something that was going to be real low mileage and not too far away from home. I'd like to go ahead and just check the balance of this drum, just because we're looking for why did we tear the transmission up so bad. So this is our little balancer, and as you can see, that drum is out of balance. It's not probably a whole lot. That's 7 grams. And it's pulling it around. So this drum could be balanced, got brought into balance fairly simple. It's not that far out. Remove a little material, add a little weight, whatever your flavor of coffee is. So that's the low drum. We will replace that drum because this engine's going to go back into a high mileage. The reverse drum happened to be a new drum. That's a replacement, new gear and drum. One of our vendors, the vendors sell these drums. I believe this drum is manufactured by JM Enterprises, I think is the name of it, but that's one of his drums. Gears are still good. Oh, let me also point out, I apologize, on the low speed drum, these gears are very serviceable. They're not too far gone. The reverse drum is a good heavy new drum. No real bad markings on it. It isn't. There's no cracks in it. We'll check the balance on it. See where we're at. Whoops. Whoops. Whoopee. That one would take a little work to get to bring it into balance. As you can see, it drops pretty dadgum quick. If you don't have the drums balanced, Henry Ford never did it, but Henry Ford didn't drive his Model T as quick as what we do. So this sets up vibration and shake. Vibration and shake robs power. It wears out bearings and causes a lot of havoc. So I like to balance everything. And that one would take quite a bit of work to do, but it can be brought in. Just find the high side here. Like I said, that's about 7 grams there. There's 14 grams coming on, and I still haven't got it to flip over, okay? So there's a lot of material that would have to be removed, and some weight added to it to get that one brought in. But it can be done. You just have to work at it. Yeah, it's a long ways out. Certainly a contributing factor to maybe running in there and throwing things out of balance enough to where we wore out those bearings in the... This again is our drive plate, the one that's around it. The square hole is now round. I put it back together and lined it up, kind of like what they had it, and just want to take a look and see what's going on with it. And as you can see, it was also out of balance. So we had 3 transmission drums and drive plate combination here that's all out of balance. It can all be brought into balance. We touched base on that on our transmission rebuild in our video, engine overhaul video. So all of this could be used. Obviously, we're going to replace the drive plate. This has some roughness on the shaft. The drum doesn't have any cracks. I might smooth this down a little bit and reuse that, or if I had a better one, I'd just replace it. But again, a lot of this, how far do you go, comes down to how you're driving your car. If you're only driving your car 500 miles a year, I know a lot of guys that are lucky if they do that. Could you use some of this stuff? Sure, yeah. Could you put it back together the way it is? Yeah, replace the bearings and the bushings and line things up the best you could and get on down the road. Guy that drives at 500 miles, it'll probably outlive me. But if you're going to be a guy that's going to take off and go out there with no trailer and no safety net, you might want to consider building it correctly. Another thing I'd just like to mention, when we pulled the driven gear off of the front of the brake drum sleeve, there was 2 keys that hold the gear in place after you've pressed it on. These 2 keys are flat across the back, and you cannot buy these keys from a vendor that I'm aware of. So if these are in good shape, not all worn out, fit snugly into your slots of the brake drum, don't lose these, or you'll end up having to buy. It's a standard key, but it's just flattened. And so you'd have to buy a set and go find somebody with a mill or grind them off to get those flat spots, because that has to be there due to the fact of this bushing that's in here. If those come in contact with that bushing, it'll collapse that bushing and you'll never get the main shaft on. So don't lose these, okay?